Alright, we're starting a brand new chapter. We're still talking about trigonometry, but now we're going to look at what we call analytic geometry, or trigonometry, excuse me. And our first section has to do with some of the most fundamental trigonometric identities. Now we've had a list of identities that we got back in chapter 4, and these should be in your memory. Now, I'm not saying that you'd have to be able to write them down on a piece of blank paper upon demand and such, but you should remember these, and you shouldn't have to go scrambling for your phone or scrambling for your notebook every time you come across the need for one of these four groups of identities. Now, the first group of identities are the reciprocal identities, and they're pretty straightforward because you should remember that sine and cosecant are reciprocals of each other, cosine and secant are reciprocals of each other, and of course tangent and cotangent are reciprocals of each other. Alright? With that stated, let's go down to the quotient identities. These two quotient identities are key. Students sometimes get these reversed, that the tangent of x is equal to the sine of x over the cosine of x. The cotangent of x is equal to the cosine of x over the sine of x. And of course, really important, just as important as the Pythagorean theorem is the geometry, the Pythagorean identities, that the sine squared of an angle x plus the cosine squared of an angle x is equal to 1. Also, almost as important as the first one, these other two variations of this first one. See, if you just take this identity and you divide both sides by cosine squared x, you'll get this one here, and that is the tangent squared x plus 1 is equal to secant squared x. The third one there, if you take the original right here and divide both sides by sine squared x, every term both sides, you're going to get 1 plus cotangent squared x is equal to cosecant squared x. Now, the even and odd identities, if you can remember that, first off, the definition of an even and odd, remember if a function, if you have f of x is equal to, if you have f of the opposite of x is equal to f of x, that it's even. And if you have f of the opposite of x is equal to the opposite of f of x, that it's odd. You can see these first four that I have here on the left are all odd functions. And of course the cosine and secant are the only two that are even functions. You need to kind of remember that as well. Now what we're going to do with all these identities, and we're going to add identities to this list in this chapter. Trust me, these are not the only groups. But what we're going to be able to do with these is that we're going to be able to use them to simplify trigonometric expressions, which I'm going to show you some examples of here in just a moment. And we're also going to be able to use these to help verify other trigonometric identities. And of course, when you're doing this, and you need to go through the steps, and you need to, of course, show your work. So let's get started with some of these here. Let me get an ink pen that I'm happy with here. And I'm happy with this one right over here. Alright, simplify, write the final form with no fractions. Now you say, well, there are no fractions to begin with. Well, there aren't. But for me to simplify this expression, I'm going to use some of these identities over here, and I'm going to probably end up with some fractions. In fact, I'm going to rewrite, since I don't see anything that's clearly obvious for any one specific identity, I'm going to rewrite these in terms of sine and cosine, which means that I'm going to be using the reciprocal and the quotient identities. I'm going to write the tangent of x, don't forget your equal sign, the tangent of x is the sine of x all over the cosine of x. I'm going to write cosine squared of x as cosine squared of x all over 1. And I'm going to write the secant of x as 1 over the cosine of x. Now, along with these identities, you have to be able to do a little bit of algebra. And in this case, when you are multiplying rational expressions, you can cancel common factors in the numerator and the denominator. And I notice here that I have a factor of the cosine of x here that I can factor with one of these two factors of the cosine of x. That just leaves a single cosine of x. And then I have this guy over here that cancels with one of these this only factor here. So that leaves sine of x times 1 all over 1 times 1 times 1. The sine of x over 1, of course, that's the sine of x. And that's as simple as you're going to get when you get it down to a single trigonometric function. Now the second problem is not multiplying, it's adding. And if you remember from adding rational expressions, you need to get a common denominator. The common denominator in this case, notice here I'm using a lot of algebra and such, the common denominator in this case would be their product. It would be the sine of theta times 1 plus the cosine of theta. So I'm going to rewrite each one of these I'm going to put a fraction bar plus a fraction bar, so that my denominator is the sine of theta times the quantity 1 plus the cosine of theta. The sine of theta times the quantity 1 plus the cosine of theta. I need a common denominator, and that's going to be my best bet. To get this to this, I would have to multiply by the factor 1 plus the cosine of theta, so I have to do the same thing to the numerator. Cosine of theta times the quantity 1 plus cosine of theta. Over here, to get this denominator to look like this denominator, I'd have to multiply by the sine of theta, so I have to multiply the numerator by the sine of theta, and that would just give me sine squared theta. Now, I'm not done. In fact, if anything, it's gotten kind of worse looking, but I do have common denominators, so I am going to not only distribute up here, but I'm going to put it all over my common denominator, which is the sine of theta times the quantity 1 plus the cosine of theta. So up top here, I have the cosine of theta plus cosine squared theta plus here, sine squared theta. Now, it's still pretty messy looking, but if you have put some of these to memory, you'll notice that in the numerator, cosine squared theta plus sine squared theta should look familiar. Look back over here. It's equal to 1. So all of this right here is equal to 1. So I'm going to substitute 1 in there. I have the cosine of theta plus 1 all over the sine of theta times the quantity 1 plus cosine of theta. Now I still have a rational expression, but you're going to see here in a second that something really conveniently has occurred here. I have a common factor in the numerator and denominator. Now they just commuted it, but that's okay, because we know that cosine theta plus 1 is the same as 1 plus sine theta. Notice how, again, I'm putting in all these steps. I'm not skipping any logic, so that when I follow the work, I can understand exactly how I went from one step to the next step to the next step. Now that's pretty simplified, but again, remember the directions stated no fractions, so I'm going to use the reciprocal relationship here and write 1 plus the sine of theta as the cosecant of theta. And I have my answer. And that's fairly simplified as well. Again, a single trig. Notice I showed my work. Okay, now, over here. I have 1 minus secant squared t all over the quantity tangent of t minus tangent of t times the secant of t. Now, if you look at this 1 and this secant squared t, you might be tempted to think, well, maybe somehow it's something to do with this. And you might be right. You might be able to make a substitution in here. But I'm thinking of this more in terms of factoring, because I see a common factor here of the tangent of t, and I know that, notice that this is a difference of squares. Now you say, well, there is no way I would have thought difference of squares when I looked at that. Well, that's why it just takes some practice. After a while, you get to be able to spot some of these kinds. All right, so 1 minus secant squared t, I'm going to factor it as a difference of squares with a 1 and a 1, a minus and a plus, and a secant of t, a secant of t. Down below, I'm going to factor out like a GCF of the tangent of t, and that will leave me 1 minus the secant of t, which is, again, so convenient that I have it written this way. Because look what I've got now. I can cancel these two guys. So now I have 1 plus the secant of t divided by the tangent of t. Now what I'm going to do in this case is I'm going to try to rewrite this so that I don't have one big fraction, but that I might have two fractions so that I can simplify. So I'm going to write this as 1 over, now this is not the only way this can be done, there's other ways, but essentially this is as good as any, plus the secant of t all over the tangent of t. Now 1 over the tangent of t, is the cotangent of t, and the secant of t over the tangent of t, there is no substitution, but remember that means secant divided by tangent. That means secant, which is 1 over cosine of t, divided times tangent, which would be sine of t over cosine of t, invert and multiply when you divide by a fraction. And you can see by doing that, this simplifies. So I have the cotangent of t plus, looks like 1 over the sine of t, which is 1 over the sine of t is cosecant of t. Now, if I had a function that somehow related those, and I know that this Pythagorean one has both the cotangent of x and the cosecant of x, but they're squared in here and they're not squared here, I believe that's about as far as I'm going to be able to take that one. So, you're going to need to make sure that you memorize the identities and use those as you're simplifying these trig expressions. Now, in this next video, we're going to do some trigonometric identities, but also, if you can see it now, show your work. If you don't show your work, it's going to be tough for me to follow your logic, and you're not going to be happy with your overall scores on those kinds of problems. So be sure to show all your steps, and please be neat, and please put equal signs in between steps when you're simplifying these expressions to show that this expression is equal to this expression is equal to this expression, and so on down the way. All right, practice, practice, practice.